A very warm welcome to all of us joining today as a part of India Space Week 2026 being celebrated under the theme Space Education and Research. Today, we are going to explore one of the most transformative technologies of our time. Is my voice coming clear? Uh, so, is my voice coming? Am I audible? So शायद से क्योंकि वॉइस मेरी वापस मुझको आ रही थी सो आई एम स्टार्टिंग Sorry for the interruption. So, very good morning to everyone. A very warm welcome to all of you joining us today as a part of India Space Week 2026, being celebrated under the theme Space Education and Research. Today, we are going to explore one of the most transformative technologies of our time, artificial intelligence, and its growing role in the world of space science, research, and exploration. As space missions become more complex and the amount of data generated continues to grow, artificial intelligence is becoming an increasingly powerful tool for mission planning, scientific research, autonomous systems, and decision making. And to take us deeper into the fascinating intersection of artificial intelligence and space technology, we are extremely privileged to have with us a distinguished academician, researcher, and space tech expert. It is my honor to introduce our esteemed speaker for today's session, Dr. Ashok Gopalakrishnan, sir, Professor Emeritus, India Space Academy. Sir is a distinguished academic and researcher with over 3 decades of experience across the fields of computer science, aerospace engineering, artificial intelligence, and environmental modeling. Throughout his career, he has served in the key capacities at prestigious institutions and organizations including NASA, IBM, and University of Texas at Austin, among others. He holds dual PhD from Georgia Institute of Technology, along with an MS from the University of Oxford and an MTech from IIT Bombay. His technical contributions include work on AI-based space mission planning systems, including projects such as Eagle Eye and Casper at NASA, reflecting his extensive expertise in applying artificial intelligence to complex space-related challenges. Sir has also been recognized for his contributions to technology and education through several prestigious honors, including IBM Web Sphere Champion Award in 2013, the Indian Achievers Award for Excellence in Education in 2017, and recognition among the top 100 global leaders in education in 2019. Beyond his research and professional achievements, he has been actively involved in space science and outreach education. It is truly an honor to have someone with such an extensive academic, research, and industry experience with us today. So, on the behalf of India Space Week and all the participants, I extend to you a very warm welcome. We are excited to learn from experience and gain a deeper understanding of how AI shaping the future helps in the space exploration. So, without taking any further time, let us begin today's exciting session. Over to you, Sandra. Uh,
I really am thankful to India Space Week for inviting me to be one of the speakers for this prestigious week. I'm honored to today to tell the participants something about AI and how it's used in space technology. So I would be starting with the program in a very short interval of time. So, yeah, intelligence is something which all of us have been hearing about it very often, thinking about it, and so on. Many of us have heard about the statement, oh, you're not intelligent at all, or you don't understand this, you don't understand that. It's not a question of intelligence being actually looked into, whether you understand this or that. It's how you perceive all these from your individual point of view. All of us have had the capacity to think. Right from ages, right from time immemorial, we have been thinking. Thinking is our something like an inbuilt thought, inbuilt action that we propose to use it. Right from the caveman, we have been thinking. He thought, if I rub two stones together, why do sparks fly out? He used that knowledge to build a fire. He built a fire to cook, to actually keep himself warm. Time rolled by, and intelligence started becoming better and better. Thought was actually it was there in the day where people think about it. What would have happened if Newton was sleeping lying down under the apple tree when the apple fell down? If he had not thought, why should the apple fall down? Would we have been in a capacity to understand the laws of gravity today? What would have happened if people, if the church, were to say that Earth was at the center and all the planets going around it? Like this, we have been rolling in time. Every now and then we keep thinking, and we have used our natural instinct to come out with answers. Man has been traveling through time, and he looked upon the stars and thought to himself, what lies out there? Can we humans be there someday or the other? And later on, he started thinking, why do birds fly? He built the airplane and he modeled the airplane according to the laws of physics for it to rise and move. Even for landing, he looked upon the birds and just tried to visualize what the birds do. Can I replicate it? So he kept on thinking and he started producing results. Birds were only there in the just a few kilometers out up there. Then he thought, as he built planes, he went higher up. But then he realized, why not I step out into the dark unknown, which we today call as space? No sound, silent. It's very eerie out there. So he built rockets and he kept on perfecting himself. he went on improving the way was performing, and he started moving out. The nearest place where he could set his foot was the moon. And it was in late 1960s that he stepped onto the moon and said, "It's a giant leap for mankind, but a small step for me." He couldn't go beyond that, reasons best known to him and known to us together today. The environment out there is very harsh. It's either very hot or very cold. You cannot, nothing is out there. You cannot do anything. There's so many, disastrous rays that could strike upon you immediately the moment you land, open out yourself onto space. So he thought, why not I send something more else? Instead of me going out there, let me send something out there which can sustain all this. But how do I tell that uh, object which I'm going to leave out there to move around and let me know how the environment is? So he started building intelligence onto those objects. And he called that intelligence as artificial intelligence because he built it onto something else, someone else. He realized that he was to play the role of God and build something that could tell him what is happening out there. So he started putting two and two together and built a vocabulary. Not a huge vocabulary, but he built it with two digits because numbers were very well known, 0 and 1. So the vocabulary started improving out there. Combinations of 0 and 1 started coming out in various forms. He built various algorithms, steps to make the system understand. And he sent a rocket out there to Mars. The objects came out of the rocket and started traveling around. We think what is there, try to get all that, do something on it, and send the data back so that we could look at it more better. So once we started doing that, AI started moving, artificial intelligence started expanding. Natural intelligence, artificial intelligence, both started working now. And the thirst for knowledge kept on increasing. The Indians were not left behind. Though we were the pioneers in rocket technology, we didn't have the capacity to come out into the world, into the open, and say, yes, we are the ones who pioneered. But still, we did it. And based on our technology, based on our understanding, we started exploring the space. Man has gone to the moon physically. Man has not gone, but he has sent rovers and robots to Mars and beyond. Today, we have something out there, even beyond the solar system, built by man, and it's radiating data back to us. That was the beginning of artificial intelligence. Why should I use artificial intelligence in space? Before I go into what is artificial intelligence, let me just take a general thing. Space missions generate massive data, so huge that it's not possible for a basic human being to assimilate all that and start working on it. Human decision making is limited by distance and time. Distance, though we have the capacity to think beyond the solar system, we can visualize. All that visualization is based on data, our understanding of basic physics and out there the environment. AI, on the other hand, enables speed, precision, autonomy, and so on. The human mind, the common man, has only the capacity to actually think over a small period of time. He is able to work mentally and physically only for a small distance of time. But beyond that, fatigue, tiredness starts enveloping. India has been one of the pioneers. Apart from NASA, India has, when I say pioneers, I only want to say that we have a lot of programs based on our understanding, based on our knowledge. We came out with solutions which was not possible otherwise. Chandrayaan 1, 2, yes, they were out there in space, but due to some problem or the other, the mission was not accomplished. And it was during COVID that uh, everything was shut down and India was back on the drawing board. During that, they worked upon and came out with Chandrayaan 3, which made a precise landing. And that was the beginning where everyone started looking upon India. Yes, Indians had done it. Gaganyaan. Yes, we have, NASA has been doing this from quite some time. Russians have been doing it, Japanese, the Europeans, and so on. But India took it up and they started doing the coming out. It was not a very quick process, slow and steady, that is going to win the race now. Gaganyaan is going to come out with many more. The entire mission of Gaganyaan is coming out very soon. But before we again actually send the human out there, we want to check it out, test it out. So we are going to send a robot. All this has given the role of AI a very prominent place in space education, space exploration, space missions, and so on. India has been doing all this work right from the late 60s when India, in that small hamlet out there on the shores of the Arabian Sea, state of Kerala, that India began its space exploration. The fathers of Indian space technology, Dr. Vikram Sarabhai, is everybody, many of us have heard of him, but a few have seen him. The present generation needs to understand that there were people like Sarabhai, C.V. Raman, and so on, Dr. Abdul Kalam, and so on and so forth, who actually pioneered many things in their lives. And they have left it. The legacy continues. And it's the role of today's younger generation, today's generation, that needs to pick up, tie the two ends, and move forward. And there are a lot of things which I'm going to discuss very soon as to how the present generation can start looking at it. So, youth in space. There, as I said, the present generation is out there, whether it is from India, the Indian subcontinent, or from any other place in Asia, the America, the Europe, and so on. Youth today has the power. And to capture that power, capture the understanding and take it forward is what everybody looks upon. Yes, the stalwarts of ISRO, right from the ages till today, they have been working out. It's only experience. They were also just ordinary people like you and me before they went to ISRO and started working together, put their minds onto work. They thought, they worked. So, and they came out with so many answers, which today we are proud. Those answers place India with top recognition in the eyes of the world. So we have, that is, ISRO has a lot of programs which today the youth can go through it. What is AI? We have been talking about AI. What is AI? Artificial intelligence. The two words, artificial and intelligence, makes us feel that it's not a human being out there, it's something other than a human being. What else can it be? It is a machine. It's a machine that actually is made to work. Computers. It's actually a machine. It works and it comes out with the results at fascinated speeds. But who has given that power to the computer? It's not someone other than man. Man has translated his knowledge, his intelligence, which is natural, into something which could be used by a machine to come out with answers at a very impressive speed. Deep learning. Yes, I just won't look at what is 2 plus 2 equal to 4, but I'll go deeper into that and come out with startling facts as to why, how, when, where these questions can be answered. I would study deeper into it. Why does the apple fall down? Yes, on the above, we know that's gravity. But what is gravity? That's one step lower. That's a force. But what type of force? That's one more step, and another step, and a step. That we go deeper into the actual question. Likewise, we make the system also to think. The computer is made to think and start working. From time immemorial, we have been hearing about Google as a search engine. Early, when it was first given to the public, it was just an ordinary search engine, which you just give the question, and the fellow goes around and gives you the answer. Many people started using Google, and it started breaking down. So, what is the big idea in having a search engine which breaks down every now and then? So people worked on it and started refining the process as to how the engine could work. So that way, today Google is not just a search engine, but it is something deeper, something more better than a search engine. I leave that answer to you folks to think about it. Pattern recognition. Yes, this is a pattern. Every work that you and I do has a pattern. So I'll give you an example. Earlier, we had the telephone books and the names of the people who had subscribed, their names and the address with the telephone number. Depending upon the city, we had 2, 3 books. Now, what was the procedure? Let's say company ABC Limited. So what do I do? The first letter A, I search. It's alphabetical order. I search there. Then A, B, C. I start going deeper and deeper now. Then I have the ABC Limited. Unfortunately, I have so many ABC Limited in a particular area. Let's say in a city like Mumbai, there are a lot of ABC Limited. they have their own ways. I will just give you an example. How do I, there are about 15 ABC Limited. How do I go to the one which actually is the one which I need? So I look upon the address and I start searching the address. So what I have started, I have gone deeper and deeper. And as I go deeper and deeper, I start coming to the particular ABC Limited that I have in question. And bingo, there's the phone number. So there is a pattern which the way I have done. And that pattern is what I recognize, or Google recognizes it now, or when it started functioning as a search engine. Prediction. So I can predict if this was the input, this was the process, I can predict the output. And autonomy. Rovers are autonomous. Uh, I would put that word in quotes. Human beings, autonomous one. Why? Because they are able to function as one which would complete the work that has been assigned to them, and only that work. They will not do anything beyond. But a human being can do something more. He is able to think more and come out with better answers. And how does AI now look into space? Early automation in satellites. Satellites are objects which are going around the planet. In this case, it's going around Earth. There are numerous satellites, weather satellites, satellites used for defense, satellites used for education, and so on and so forth. Each satellite has got a particular task to perform. And if that is done, then the satellite is working. If it fails, then we are at risk. Supposing a satellite for defense has failed, then there is the country's security is at risk. So we use mission planning, any mission that needs to be accomplished, one beyond the human intelligence, AI comes into this role now. So the Mars rover, the AI evolution in space, the Mars rover, you see all that over there. Early satellite communication, mission planning, Mars rover, anomaly detection, and so on. The Mars rover had this, it was designed, um, whether it is perseverance or curiosity. These are two rovers that were designed based on other rovers that were thought of way back in the 80s, late 80s, 90s. Even India on Chandrayaan 3, the little fellow, when he came out, though he lived, it was just a small toy-like structure. Though he stayed there for a short interval of time, not as long as perseverance and curiosity, he was able to do something. He was able to and that gave India that feeling and the world that feeling, yes, here is a country that can accomplish better and better in future. So the next Chandrayaan 4, Chandrayaan 5, and so on, we have rovers which will take over, which will function out there on the moon and take out samples and bring it back to Earth. If the Americans can do it, why not India? That's the question mark. And I personally feel that we are not going to be left behind. In fact, we are better. Today, Indians are proud that NASA has requested India to jointly partner for the moon mission. Yes, ISRO has been. We are honored to have been actually requested for a joint participation. The Mars rover, what does it do? Autonomous navigation. It identifies hazards. It identifies a path. a path that is, if there is a rock in front, the fellow senses that rock and moves away from it and goes past it. You can adjust the satellite orbit. Supposing there is a satellite and there's a stream of rocks coming in, and the satellite can be shifted. And when the danger passes, it can continue on a designated path. Anomaly detection. You can predict spacecraft system failure. This type of detection, this type of autonomous navigation, this type of image recognition is only there in AI, because AI has it has the capacity to look at exoplanets, planets out there in space which have the capacity to actually replicate life. There are more than 3,000 planets which have been identified that can replicate human life. But it's not that today or tomorrow humans are going out there and life is going to be transferred there from Earth. It only means that, yes, these planets are capable of helping life to grow, sustain itself. Different galaxies. There are hundreds of galaxies out there. We are just in one of that. It's a small speck in a huge haystack. You can today image recognition, you can identify all this exoplanets, galaxy detection, processing telescope imageries. You have telescopes out there on Earth. You have telescopes like the Hubble telescope out there in space. Because of so many issues for like light on the surface of the Earth, we thought that the best place to keep a telescope which can detect different distant galaxies would be in space. So we built the Hubble telescope. The Hubble telescope today captures images through various means and sends it back to Earth. It does the work there and sends it back to Earth also. But instead of sending it back to Earth, why not humans stay out there in space? So international space stations came out. So there will be a group going up from here, from Earth. They spend about some time, a fortnight or 3 weeks. They do the work in the lab. They do sleep, eat there, and they get the data out. And when after a certain period, the next batch goes in, and the previous batch comes back. So there is a continuous process, a process which will be helpful in identifying that particular that particular place for you where you can think and stand and that place is the space. Nobody is going to question you. Nobody can tell you this is my area. You're there and you will continue to be there. We have seen movies, the Hollywood movies, we have seen Indian movies, and so on. We have seen all types of movies on space. The theme, space, has been recognized by everyone. And this is what we have, the path planning and the path planting. So you can plan your path, you can plant your path, you have the anomaly detection memory which goes out, you can have a standby and so many more things. You can look at climate. Yes, that's a very important aspect. Climate, all of us have uh, we understand about climate technology. Yes, today we have been experiencing not just the younger generation, but the generation which is nearing completion of their stay on Earth. The changes which are taking place in the climate. No rainfall, regular rainfall, which was there in 60s, had been at 70s, early 80s, and so on, they have started being, it's getting cut off. Heat has started becoming the talk of the day. There's no ice age, thank God, but we are slowly getting into the heat age. So all these things are something which we need to realize, which we need to understand. And that is, we translate all this into our fellow buddies, the rovers, the robots, and so on, who work exclusively on the intelligence supplied to them, as we call it as artificial intelligence. I've been talking about artificial intelligence, but let me go one step deeper into artificial intelligence. Now, just think, um, we have started school. We will go back in time and think of the time when we first stepped onto school. Mommy and daddy have come and left us. We scream, say, we rebel and say we are not going to school. We cry, we yell. But mommy, daddy, and the teacher, they are stubborn, and we have no other means but to enter the school gate. There the teacher starts teaching you about the way you need to conduct yourself, not just the way you move yourself, but vocabulary. A, B, C, D, the 26 alphabet we are being programmed into us. So there is a supervisor, and the supervisor is actually giving you the uh, the way you need to conduct, the way you need to talk. For example, TALK. Think of that when we were there in school. We were, as children, we used to say talk. The teacher corrects us. It's not talk, but it is talk. L is silent. There's a supervisor who corrects us. And that is being programmed into our mind. And as years pass by, we start learning more and more meanings, sentences, how to greet others, how to conduct ourselves in public. Translate this now into space. We are given all this to the robots, and the robot is now going to work. I've given you a small example, exoplanet detection. Now, many of you may be aware of an exoplanet, but there are some who are not aware, so I'll just step onto them. You think of a light source, and you see an object which is coming in the front. Now, what is the color of the object that you see? Laws of physics again, the side which you see of the object is not the side which is behind it, but in front of the light source. The object, the side which you see is dark. So as this fellow moves, this is the light source, and this fellow moves, we start and we study some of the image recognition, using the image recognition method, that there is something which is moving. We look at this as a sun and this as a planet. As the sun, when the planet enters, it becomes, you see a dark object moving from left to right. And as it moves, after some time, the fellow disappears. And later on, the fellow reappears on the other side. He disappears on one and he reappears on the other, which means that he has gone in an orbit around the light source. So these type of detection, these type of, so now you understand that, yes, there is a planet which is doing this. I go one step deeper and I study the chemistry of the planet. Then I feel, okay, there is water on the planet, hydrogen and oxygen. So there may be something else. Likewise, I start training myself. And this is what supervised learning says. Spacecraft fault prediction. Now, when I look at a satellite, the process of looking at a satellite, studying the satellite, looking at the various functionalities of the satellite, the radio signals which come back, you send some instructions, and all this, we know that it is telemetry. Now, when everything is functioning, the satellite is working normal. But when I send a signal and the satellite fails to answer that, then there is a fault, and we try to identify the fault and correct it. Satellite image classification. You can have different uh, aspects of the terrain, like the crater, ice cap, desert. Everything can be looked into. It works best when we already know these categories and have labeled examples. So I know that this is how a terrain looks like. That's what I've seen on Earth. This is how a desert looks like. That's what I've seen on Earth. I've seen ice age, not I or you personally, but humans have seen ice age, and it has been there in the volume of intelligence that has been there for years. Now, all these are termed as supervised learning. Now, just for a moment, the uh, the planet is born in front, and in front of the light source. So we identify that as an exoplanet. Don't ask me why EXO, but it is exoplanet. Uh, that's besides the point now. So as we train ourselves, as perseverance starts taking a morning or an afternoon or an evening stroll on Mars, he identifies something which he has not been programmed. But because of, maybe because of his intelligence, he is able to come out with some answer for that. And he finds some hidden patterns in unlabeled data. There, we are not supervising the fellow, it's an unsupervised learning. And example for that, galaxy clustering. Now, galaxy clustering, you can group different galaxies and come out with uh, various other answers like shape, brightness, and so on. Shape. Now, everybody thinks that, shape is something like a circle, or we all thought everything has only one shape, and that's a circle. But then later on, there were different other shapes, elliptical shape, and octagonal shape, and hexagonal shape, and so it started coming. Elliptic shape is something which we are very familiar with when we look upon in space. So these type of answers, cosmic signal discovery, unusual radio signals, possibly from a pulsar or a radio burst from a different source, all these have started being identified. They were not there. We never knew anything about them earlier, but we have identified something which is coming out from space. And there have been recent set of signals which have been traveling through space for quite some time, and it has reached Earth in an unusual pattern, which we might look at it as something out there is trying to send a signal to us. In fact, we have already sent a signal to creatures in outer space saying that this is it from Earth, and Earth is occupied by human beings. This is the way a male looks like, and this is the way a female looks like. Our DNA structure is this and that. It's a big plate which has been sent out into space. And maybe these aliens have seen that and they have sent back a reply. And we know that they're not just next door, they're out there in space. If there is a planet or if there is a galaxy which can sustain life, life not exactly like our life, but life, then we term that as an alien. So supervised learning is a teacher who gives answer keys. AI learns with guidance. Unsupervised learning, AI is an explorer, grouping stars into constellations without knowing their names. Though there are so many stars out there, we have identified only a few and we have given them names. But there are stars out there which we have not identified. So unsupervised learning was talking to you about, the data out there in space is huge. And it's such a huge data that we need to mine the data to understand that. AI is able to do it without any problems. So it automatically detects the analysis, the exoplanet discovery, cosmic evolution, and so on. It reduces the human workload, accelerates scientific breakthroughs. Now, how does AI mine this data? When I look at exoplanet, what is that which I'm looking at? I'm looking at primarily a planet similar to Earth, which can sustain life. Now, AI looks at all this and it scans the light curve because, as I said, there's a light curve, a source, and a dark object moving in. And as the object comes in front of the light source, it becomes dark. So, brightness versus time. So, here in that circumference, it's bright, but away from the circumference, it's dark. So, how long does it take to move from the source of the starting point of brightness to the end point of brightness? And how long does it take to come back? So these type of uh, data, these type of surveys are done by AI, and this is done through using the Kepler telescopes. Then we have deep learning models, which actually distinguishes between true planetary signals from false or positives. False or positives can be even in the instrument noise. So this, we are looking at a candidate identified as a planet. And when we look at the planet and the candidate, anything apart from what we are looking at, be it the noise or any other signal coming out, we try to remove that, filter it out, and only capture what is needed. AI does that. So we have more than so many new planets, exoplanets, the recent data which shows from Kepler's data now apply to TESS. Now, TESS is a different type of telescope which is used to actually look upon, study these objects. And we put all this in a place where it can be actually looked taken by researchers, taken by students, taken by public to actually study and come out with startling facts. Then we have cosmic event discovery, supernovae, fast radio bursts. AI detects models that shift through telescope time series. Now, if I look at train my telescope onto a particular object and through the telescope, after some time, the fellow disappears. So it could be that could be as a result of trading off that object, maybe a supernovae or some radio burst which came at a particular point and disappeared. Gravitational waves. Now, gravitational waves, by the name itself, you can understand that gravity, it actually projects a wave, let's say, and a black hole for that matter. Two black holes collide. A black hole is one which actually has intense gravitational effect. Two black holes, they collide, and you can imagine what would happen to even light is not allowed to escape from the black hole. So what power, what force it should have. And when they collide, you can expect what happens. So when two objects like that collide, basic physics again says that they set out a wave that can transmit over space across a period of time. The sun, the closest red hot giant, it's very hot at the center and it's moving. Nuclear reactions take place, and the force starts moving outward because there is no other way out. It cannot go inside again, so it starts expanding. The force starts moving up. On the way, he breaks open so many, and makes a path for himself. Again, the path closes on because it's molten over there. As he moves forward, he keeps on shifting everything besides, and he comes to the surface, the corona. And when he comes to the surface, what does he have? This movement actually adds on. And as he comes to the surface, he lets loose a huge burst, a burst of molten gases, and you can just see the amount of energy that it flares out. That rises to hundreds of miles. And as it rises, it comes in contact with so many other planets. It's over there. And if Earth is in that path, imagine what could happen. Nothing much should happen to Earth. Only thing is that could set off a geostorm. That could set off a blackout. That could set off a communication breakdown. When all this happens, what is life out there? There's no life. When communication breaks, everything breaks. When a geostorm breaks, everything goes out. So all these things, the cosmic events are discovered. They are identified. And we have the Aditya L1, the moving solar observatory out there in space at a particular point. known as the Lagrange point. At that point, where one portion of the satellite is of Aditya is facing the sun, while the other portion is looking back at Earth. So at every second, whenever there is a flare, he captures the effect of that flare, radios it back to Earth, and the flare it's moving at very high speed, and you can see as it moves and it gets caught in the Earth's magnetic field, uh, what will be the effect? Aurora, the green light, which you see at the Pole, is only because of a flare that has taken place. We have had incidents where there's a communication breakdown, where there's so many things that have broken down. And even students who are trained in such an event to take place, they can identify what and when such a thing could happen, and some sort of recovery mechanism could be looked upon. Pattern recognition. So we have a lot of clustering of data, grouping together of data, which form a particular group identified. So we can identify the pattern which is out there. Cosmic events, they actually deliver a particular pattern. And knowing that pattern, studying that pattern, we should be in a position to understand what is going on. Atmospheric characterization, spectral analysis. You can identify atmospheric components. Now, when I look at a spectrum, when I see the blue, green, violet, etc., the frames of these colors identify a particular gas, identify a particular metal, identify a particular aspect of what the mission tells me. If the mission tells me to identify water on Mars or identify water on the moon, I immediately take out a sample and start training myself onto the spectral analysis and the study the shift between the red and the blue lines and so on. Efficiency gains. So when I look at the statistical aspect, statistics has played a very important role in space technology. So when I look at statistics, you see that averaging out over a period of time, you will be able to look at so many things that need to be studied, that could be studied, that will be studied. From hours to seconds, if you bring down and study the type of anomaly that is forming out there, look at a satellite image of, let's say, a landslide. You could, at a particular point, when I look at the satellite image and I study, I'll be able to pinpoint so many aspects. The point from the epicenter of an earthquake could be identified. The tsunami, the origin of the tsunami could be identified, and so on, using statistical means. So I average it out. Statistics, as I said, plays a very, very important role. So the supervised learning techniques used are CNNs, trained on labeled transfer data, unsupervised learning, clusters of spectral features which discover unusual phenomena, generative models which can simulate planetary atmospheres, and then hybrid models combining physics-based simulations with ML, machine language, for better generalization across instruments. All these are AI-based techniques. And when I look at and combine each one of them, I'm able to train myself onto the space. The space science, the technology of that unknown world has been bothering us. Many of us might think, why go into the unknown world? Why not we concentrate on the known world? The known world today Earth, for that matter, has sort of it's the natural resources have come down. Oil has come down, and we are in the process of finding more oil, more petroleum. Food has come down because of various means. No rainfall, the temperature goes, there's a large variation in the temperature, the soil structure, because we have just been exploiting. Humans have exploited the earth. Humans have exploited nature. So when exploitation takes place, the lifespan of each one of these starts reducing. And when it starts reducing, we humans face the brunt of it. So India is steadily emerging as a very strong player for AI in space explorations. They integrate machine learning into missions like Chandrayaan-3 and so on and so forth. So AI is being used for autonomous navigation, spacecraft health monitoring. You can satellite. How long will the satellite be orbiting around Earth? It cannot go on for ages together. It could be there for months or for weeks or months, but invariably it might go on for a couple of years, even beyond that. Voyager 1 and 2 were programmed for just about 50, 60 days or so on. But it's 15 years that the fellow has been going, and he has gone past the our solar system and has entered into deep space. But still, he is able to send some signals. Imagine the technology that time when you listen to this. What could be the technology that time in the early 2000s, in the late 90s? Imagine, you were not there, but I was there. I could see all this, the technology. What you see today in when you get the results out there in seconds, it used to take days and sometimes weeks for us. I remember all that, and I really am, I think aloud and think for myself, how did I actually solve all this? It's something which is beyond explanation. ISRO is planning a Antariksh station, a home out there in space, maybe in 2035, if everything goes well. A Venus orbiter, Shukrayaan, Samudrayan. Now, ISRO says, well, why not? Why go only into space? Why not we go deep into the water itself? Samudrayan. We try to, let's see how life can be sustained out there. Uh, how does everything behave out there? Yes, theoretically, we look at so many things, and Samudrayan is one. We just from the data which we have, we can visualize what would be the after effects of there in the deep inside. But we are not sure because no man has gone beyond a particular depth. And out there in space, no man has gone beyond a particular height. So ISRO uses AI in space exploration, mission operations. AI supports trajectory, the design of the way, the path the rocket has to go. If there is some problem in the path, so it should be able to change its path slightly and move. Place the satellite in its designated orbit. Cannot place it anywhere else. So it places it in its designated orbit, and then the fellow starts moving. So imagine when the satellite is moving, asteroids and rocks and so on, they're flying past, and any damage to the satellite is the end of the satellite. So the satellite is able to shift itself, avoiding the roll of these rocks onto it, so onto itself, maneuvering the orbit. Chandrayaan-3 soft landing. How did it happen? It happened only using AI-powered hazard detection, navigation system. When I say hazard, you cannot have that lunar module here coming crashing onto that. Even if it crashes, if it sustains the impact, there could be rocks there, or instead of placing the satellite in like this, it could be like in this fashion. That means the one of the legs is on a higher rock and the other fellow is on a plane. So all these aspects were actually worked upon every second of its landing. The lunar module is AI trains itself onto a perfect landing based on the images that is being captured at that moment. Processing data, machine learning is applied to satellite imageries and so on. Space robotics. You have ISRO, as I said, ISRO is sending a robot first before humans can go. And it's a humanoid robot, Vyayomitra, and it's a lady. And she goes out there, and ISRO studies what type of effect the extreme conditions would have on humans. ISRO is also planning out so many other things. Way out there in Ladakh, you have these astronauts who are programmed to go out there into space. They live in an environment which is simulated, something like Mars. No outside contact is permitted. No inside contact to outside is permitted. They are out there and everything is closed. Everything is provided, food, the water, clothing, etc. And the whole environment, the temperature conditions, everything is simulated. You need to see how the human beings, they actually uh, relate themselves. Vyayomitra, she's going to fly out there in 2026 to validate technologies for India's human space flight program that will happen in 27-28. Big data analytics. So AI is used to ship through massive telescopes and satellite data set. You have so much of data that, as I said, human beings pay to understand them. So AI, which is being now used, trains itself onto the study, faster identification of exoplanets and cosmic events. Now, all this is exciting, but what is more exciting is out now. It's for the younger generation to actually train themselves. The older generation have done the framework, they have placed everything, and it's now the younger generation to build. Foundation is laid, and now to build. And ISRO has actually pioneered in this. There's an annual competition which encourage students to design autonomous surveyor UAVs, unidentified aerial vehicles. I call them as unidentified because when these drone-like structures, they look upon with so many aspects. You can and one of these aerial vehicles can be unmanned. So we are not going to man them. It's going to be controlled. UAV. The 2026, this year's edition focused on a SWAM robotics and AI-driven navigation in a GPS denied. Now, when I say this, the 2026 competition that ISRO had designated a particular area out there in the UR Rao Satellite Center in Bangalore. And many colleges, many students and researchers and everyone, they were encouraged to actually take part. What needs to be looked upon is that a swarm of drones, it's not one was the year before. A swarm of drones are being, they come over this. It's a simulated environment and no GPS is allowed. That means you have no contact over the drone, the path, and so on. The drone identifies itself. It actually photographs everything. It's supposed to land at a particular place and then move from there. So the swarm of drones, when they actually come over, they could hit against each other and all that. But you have to program them in such a way that they land there without any problems. And it's only through AI. GPS is denied here. Academic collaborations. ISRO works with many IITs, universities, institutions to actually make the younger generation realize that is an exciting our system out there. Everybody is encouraged. I remember the time when I was also there as a professor emeritus in one of the autonomous colleges in Coimbatore. So through the ISRO Space Tutor Center, through competitions, and even the NASA Space Hackathon is one such area, one such collaboration where you, as an individual, are trained to work out. These space agencies, they encourage students to think and come out with solutions. Policy push. We have so many startups today, and you all know about the latest startup which was able to fire away a rocket, the entire thing built by a private company out there into space. ISRO helped in the launch, and with that success, India has gone one step higher in that climb. And there's a policy which has been given out by the government, which is going to offer many such many sort of incentives. And this is Viksit Bharat, made in India for India. So ISRO scientists, the role of ISRO onto the startups, the innovative ones, which are going to be there, are being encouraged. Students have launched many satellites, students nano satellite from India. There are many universities which have come out with successfully launched their own satellites, again with the help of ISRO. The satellites are built, programmed by the students, and that fellow is tested thoroughly before at ISRO in Bangalore, and then we look upon the launch by ISRO, and successfully many have completed. Yes, there are few which had crashed, but that is not the one to think about. To actually, when you step down, when you fall down, there's a helping hand that pulls you out, just like the phoenix which rises from the ashes. So you look upon all this as a stepping stone, but there is an exciting field out there, space, the ultimate frontier. Startups like Skyroot Aerospace, Pixel, Agnikul, etc., they leverage AI for satellite imaging, launch vehicle optimization, and so on. AI in Earth observations, so Pixel uses machine language learning for hyperspectral imaging satellites. Then Skyroot Aerospace successfully launched Vikram 1 in July 2026, marking the country's first privately developed orbital rocket. This milestone has positioned India alongside US and China as nations which have this capacity. Agnikul Cosmos, Astrobase are also advancing indigenous launch technologies. A little about these. Skyroot Aerospace Vikram 1, date July 18th. First all private orbital launch from India, lifting off from Sriharikota. And there are so many other things. And which and they're working on the next stage also, and through the next stage, according to reports, would be looking up at reusable ones. Developing Vikram 2, targeted for 2027, launching 1,000 kg payloads, and so on. Agnikul Cosmos, Agniban, modular, customizable, small satellite launch vehicles, and so on. They complement Skyroot in the small satellite market. It's exciting, definitely. Astrobase, space technology, Everest engine, privately built, a full flow stage combustion engine that is enabled to actually power reusable rockets. Engine was unveiled in August 2026, and very soon you'll be hearing from them. Government support. Now the government is ready to support all this with some incentives and so on, and 100% policy impact. These measures following the success of Vikram 1. It is actually designed to accelerate India's space economy, foster public-private partnerships. Now, strategic advantages. Why India is so well advanced now? First, the positioning of the launch site. East Coast launch site, closer to the equator, Sriharikota, and it offers excellent positioning for equatorial and geostationary orbits. So the more, even in the US, the more you are closer to the equator, the better it is for the launch. Some people might question, then how does uh, Russia come out? They have no oceans around them. They have the desert. Russia has its own ways of launching and uh, getting it back, re-entering the one. They don't land in water like America or India. They land on land. See, the way Russia is coming out with solutions is totally different. They have perfected that way. French Guyana, the French, or the space agency in France, they have their launch pad in French Guyana. It's sort of an island, and from there they launch it. There you have the Japanese, you have the Chinese, and so on. There are so many ones which have their uh, launch pads closer to water because it's easy to recover the remnants of the uh, rocket. Global positionings, startups, they aim to compete not just on cost, but on launch frequency. India is the first nation to help other countries, even NASA, to launch. Because the launching facility in India is much, much inexpensive when compared to the other, when compared to even NASA. So everybody comes to India to launch their satellite, and India has emerged out there as a powerful country, only one in the world to do this. So when I look upon the pictures, you have by 2027, you have India to have 3 commercial small launch vehicles. This is Agnikul's launch vehicle. Then Agniban, the Skyroot Vikram 1, Pixels, this is a hyperspectral satellite, and they have their own, and this is Astrobase's Everest engine. You know, all of us have been looking up, hearing so many things about the launch vehicles, the PSLV, and so on, the GSLV, the Bahubali. These are powerful rockets, that can take up launch even 1,000 kg satellite or even more. In fact, ISRO was successful in doing a 3,000 kg satellite for the US in December. Yeah, there have been failures, but as I said earlier, failure is only a stepping stone to success. When we fall, we and correct ourselves, the result is something which you can't dream. But you're allowed to dream here. So when I look upon all this, uh, together these startups, they complement ISRO by actually launching their own rockets, by advanced propulsion, satellite data analysis, and so on. It positions India as a competitive hub, the global space economy. This is 2022 Pixel, the first hyperspectral satellite was launched. 2026 Skyroot, first private orbital launch. Then August 2026, this was the Everest engine was unveiled. 2027, it is expected Agnikul Agniban. And beyond this, we are going to have so many other systems, rockets coming in. Everything is there out here in the open for you and I to take advantage. When I look upon the global comparison, America, it started in 2008, 10, and so on. You have at every stage, we have the type of systems which are developed, you see them being launched. Even in India, you see it goes in a steady space. You have China, you have so many other, this is China. So you have India being positioned not at the third place or the fourth place, but at a position two. And it's a very, very heartwarming in a thought that when I look upon my country being positioned as one of the most powerful countries in the world, just besides America, I feel proud of that. So here is the something which relates. It actually visually places India from 2026 to 27 breakthroughs alongside global milestone from 2008. So US, India, China, and Europe. So you have India, you can see India being positioned and being acclaimed as one of the best in the world today. So opportunities are there. Well, what type of opportunities are there? AI-driven space research. Students can work on data mining, with data which is obtained from telescopes, satellites, using AI. ISRO's collaborations with various IITs, IISc, and so on. Private space startups. You have lot and lot of them. Every day, space startups are coming up, and they have internships also. Many offer internships, fellowships for students in computer science, aerospace, and so on. AI and satellite applications. You have climate modeling, you have Earth observation, you have disaster prediction. All are out there. Students can contribute to AI-based image classification for agriculture, urban planning, environmental monitoring. Space robotics, you have ISRO's Biomitra, the humanoid project, which is there for future lunar and planetary rovers, which rely on AI. Then entrepreneurship. There are in space, the body which is the central government body, which actually governs. And today, in space has come out with lot of incentives for space startups or even startups that have innovation ideas. Now, what are the skills that you can cultivate? If your domain is AI and ML, key skill you should have neural networks, data mining, and computer vision. And for example, the tools are TensorFlow and PyTorch. If you want to work in space stations, key skills are orbital mechanics, propulsion, satellite design. The tools that you can use are MATLAB and ISTKey. You've got to be good in that. If your domain is data science, you should have big data analytics, visualization as a key skill. You should be thorough with Python, Pandas, and Tableau. Robotics, if your domain is that, then key skill is control system, sensor fusion, and you can work with ROS and OpenCV. So students out there, the next decade, 10, 15 years from this day, you can see AI-powered missions to Mars, Venus, and beyond. India's youth can lead the frontier. It's not just they're going to work only there. You can lead the frontier not just as engineers, but as scientists, storytellers, and innovators shaping humanity's cosmic future. So hundreds and hundreds of openings out there. I've given you some of them, and you can contact your colleges, your department, and ask them to contact ISRO, go for internships, go do your projects, do it well, study well. The future is there. It's a bright future out there for you. Make use of it. And finally, we have there's a lot of uh, opportunities, as I said, pioneers who are going to be there, the Indian youth. You should be able to discover exoplanets, cosmic events, help in doing that for the fellow countrymen and the world. Building satellites and rockets, advancing space robotics and AI, innovating with AI and tech startups, exploring Mars, Moon, and beyond. Then you can actually look at satellite, you can chat with satellite and help in communication process to a large extent. You need to be dare, you should to dream, but aim for the stars. These are the ways that which I told you. Internships, competitive challenges, space hackathons, student satellite design competitions, robotics, drone challenges, then innovation. You have ISRO Space Innovation Cell, then Atal Tinkering Labs, Startup India and Space Acceleration. Learn and build skills, coding, AI, and aerospace engineers. Join space clubs, societies. Launch your ideas. Come out with ideas. You need to think, and thinking is the only thing today. Just like we did 40, 50 years ago when there was no internet, the communication was absolutely zero. We had to think ways and means how to come out with, how to reach out to others out there, crossing the seven seas. I needed help. How do I look upon? I don't have internet, but you should be able to look at that. I was there in those days when there was no internet. I never saw a laptop till I went abroad. I never had the opportunity to actually play around with my mobile till I came back to India. I never had the opportunity to look upon, because the way we are looking at uh, Instagram and so on, I never had that opportunity. Whether it's good or bad, I would call it as an opportunity. I never had that. But only thing which I had was communication, thinking, and how to make my dream come true. That is what I want all the youth today think and succeed. So this summarizes whatever I just spoke about. And you can be pioneers, you can do something for the country. And look how Skyroot, Agnikul, Astrobase, and so on, other startups, they have been developing so many things. And yes, there are small startups, there are big startups, there are, but everyone has one thing in mind: do something for space, do something for my country, do something for which I people not only thank me, but will also look upon me in near future as a person who was an innovator. India's journey in space is no longer is just a mission. It's about minds. And when I speak about minds, uh, I speak about you and me. The next decade belongs to our youth who will harness AI, robotics, innovation to propel the country into the frontiers of Mars, Moon, and beyond. From classrooms to launchpad, every idea matters. Invariably, it is not just those four domains which I spoke about. There are endless set of domains which can actually propel space technology, space science. Every student can be a builder, a coder, and a dreamer. And together we can transform these events into rockets, satellites, and discovery. This is our call to action. Dare to dream, join the revolution, launch India into its brightest depth. So finally, as we stand on the threshold of a new era, India's journey from dream to launch is not a distant vision. It's unfolding before our eyes. Fusion of AI, coming together of AI and space science, is empowering our youth to become explorers. Every idea, each idea born in a classroom, each experiment conducted in a lab, each dream nurtured under the night sky, it contributes to the nation's cosmic legacy. Together, let us ignite curiosity, inspire collaboration, and propel India to a future where imagination not only fuels discovery, but also becomes a beacon of possibility. The stars are not beyond reach, they are there next door for you. Reach out to them and go towards them. Bring forth your intelligence, your thinking capacity to the welfare of mankind. I'm ready for questions now.
Thank you so much sir, for such wonderful and insightful session. We'll now be moving towards the Q&A session. So to all our participants who are joining us, this is your opportunity to interact with our esteemed speaker and have your questions answered. So if you have any question related to today's session or the role of AI in space technology, please drop your questions in the chat box. We will be picking up your questions from the chat and presenting them to our speaker. So participants, feel free to send your questions. So we'll be waiting for the participants to drop their questions in the chat box and read it out for you. So let's wait for a minute or two for the participants to drop the questions.